All right, hello everyone. My name is Julius Chapman, and welcome to the Astro 154L Astro Lab. You can all call me Chapman Sensei. It's usually what I go by in my Astro class. Put it up on the board here. And this is the astronomy lab. So what we're going to do today is we're going to go through the syllabus. We're going to do a safety, little safety sheet to go through and train you on how to handle the lab safety. And then we're going to have an intro lecture and then we'll do the first assignment today. The first assignment is going to be extra credit, and then I have another bonus assignment that I'll add at the end. And after that, we're free to go. So I'm going to go ahead and hand out the syllabus and safety guide, and we'll go through the syllabus first, then the safety guide, and we'll go from there. Keep passing. Everyone, I'm going to hand you like 2 papers, so just pass both papers all the way down so everyone's got one. Oh, it was just 2 of that?
Do the same thing.
You said syllabus? Safety guide. You need one of these? That's the syllabus. You need a safety sheet. So is everyone in front row good? Or no? Do you need one?
The training one. The syllable.
Oh, you need one of these. You're good?
Yeah, got it. Perfect. All right. And I think I need the one that you just gave me. Yeah. Maybe.
Alright, so I'm handing back like 2 papers, so everybody like grab, like, just send them both down all the way through. Everyone got stuff? Very good. All right, so we'll start off reading through the syllabus. We'll do the safety sheet. got things for you. All right, so let's take a look at the syllabus. So again, this is Astro 154L. This is the spring 2016 is what it should say. We can be in 2015. So I'm Julius Chapman. This is, you can call me Chapman Sensei. That's what I go by in class. My mailbox is in Live Oak 11130. It's the building adjacent to here. It's the Live Oak building. It's the what you do is like the main office. You can go in there, and if you have something to give me, just tell the secretary to put it in my box. Say, can you give this to Chapman Sensei? And you sign for it, like you date and time it. Class time is from 11 a.m. to 1:45 p.m. You all know. It's in 2104. It's this room. My office is Live Oak 1118. It's also in the other building. It's in Live Oak, the physics building. My office hours are from Fridays. They're before class, from 10 to 11. But I'm also available by appointment. So if you can't make the assigned office hours here, then you can just say like, okay, when can we meet? And we'll schedule a time outside of class that we can meet. I'm pretty free as far as my schedule goes. You know, I got a pretty big gap between my my early morning classes and my grad classes at night, so we can maybe fit a time in. Let's see. So the material you'll need for class is you're going to need the lab manual, of course, which is this here. Astro 154L lab manual, and you'll also need one of these babies, the star wheel. So pretty soon we're going to be doing the star wheel lab, and we're going to be needing this. As far as the lab manual goes, the first couple of labs are going to be handouts. Like today's lab is a handout, and next week's lab is going to be a handout. Next like 3 labs are handouts, so it's all right if you don't have it yet, but please try to get it as soon as you can. You're going to need it because all the information is in this lab manual, stuff that you're not necessarily going to get in the lecture, and all the sheets where you put your information, the data sheets, are going to be in the book here. So course description, introduction to the techniques of observational astronomy and including data acquisition and interpretation. This course is designed to be independent of the lecture course, the Astro 152. Just a quick show of hands, how many of you are in the lecture course as well? Very good. Who do you have? Damien Christian. Okay. Tobias. Cool. Very good. So you're going to get a lot of information from that, which will help with this. You know, they synergize well together. But the fact is, if you're not taking the lecture class, the 152, you don't need to worry about it. I'm going to cover everything you'll need to know for the given lab that day here in the class. So. Course objective is the testing of the astronomical hypotheses by using data from observations of the moon, planets, sun, stars, and galaxies. General education, so this may be used to satisfy the lab requirement in the general education, the natural sciences, provided that the lecture course, the 152, has been completed. So it will make that requirement if you've completed the 152. So here's the course schedule. Today we have the introduction, we have the organization, the safety, and we have the lab 1, which is going to be the size scale of the universe. It's going to be what the lecture's on. It's a quick lecture, quick lab. See, we have our spring recess. We don't have any holidays for this class, so we have to make every class. And our practical exam is on the 6th. So that is the course schedule. Oh, we have our first quiz here. So so yeah, that's how it works. We have our quiz and we have our practical exam. We'll get more into that in a bit. But the quiz is going to be, tentatively, it'll be on the 18th. You know, I might move it around, but of course I'll let you know ahead of time by a lot when the quiz will be for sure. So here we go, course requirements and methods of evaluation. So first, no drinks or food items are allowed in the lab. Bottled water is permissible. So I get thirsty. I like to have my bottled water, but we don't want any kind of other drinks. You know, any kind of open top drinks like sodas or anything like that. We don't want to get anything. We don't want any spills getting on the machines or anything like that. Attendance and participation is mandatory, so do not miss any labs unless it is absolutely unavoidable, and let me know ahead of time if you know you're going to miss a lab. So if you do miss a lab and you let me know ahead of time, then we're going to work towards a solution. We'll try and figure out how we can get you to make up the lab, and what that entails is going to another Astro class besides this one and doing the lab there. But since my lab is on Friday, all the labs that are doing this lab, or today's labs, have already done the labs. They've done it earlier on in the week. So you need to let me know ahead of time by a lot so that I can get you in on somebody else's lab. I have to ask the TAs. If you tell me after the fact, then everybody has moved on to the next lab, and you won't be able to sit in on somebody else's lab because they're all doing something completely different. Yeah. So please try to make every lab. Each student will conduct his or her own experiment for each lab, and each student must turn in his or her own lab. When you go to turn it in, I expect everyone to turn it in to me individually. Like, don't bring other people's work up with you. Just hand me the lab, your own lab, and I'll say, okay, this is yours, I accept this, that sort of thing. They are all graded on a 10-point basis, with correct data taking and answers taken into consideration. Your lab will be turned in at the end of each class period, and you'll be graded and returned to you by the beginning of the next class period. So you'll turn in the lab at whenever you're done with it, and I'll grade it and turn it back to you the next week. You have to show your work when you do calculations. Just writing down the final answer will not give you credit. Do not use the internet for answers. This is a no internet class. We all have computers, but we all have cell phones, smartphones, but can't use the internet for the answers here. Usually, it's all very straightforward. It's either in the lab manual or it's in the program where you can come ask me if you need help. In fact, today's lab, number 4, is going to require a little bit of math. Not too much, but I expect to see calculations on here showing that you understand why you get the answer you get, and not just, you found the answer on the internet. You must have answer sheets from the lab manual when you turn in the lab. So I kind of want all, like tidiness is nice. So if you give me the answer sheet from the lab, like 30 setup, to answer the questions, which is why it's important to get the lab manual as soon as you can. If you turn in like a photocopy page or just like, lined paper with handwritten stuff, and, if you make it really neat, like I'll accept it, up to a certain point. If we're like 5 weeks in and you still have the lab manual and you're turning in everything by hand, then, I'm going to be a little upset. If it's really messy, I'll start, I'll take points off of it. That's my policy on that. If you have a question in the class, please do not hesitate to ask me. Keep in mind that you will benefit in direct proportion to how much time and effort you put into solving the question on your own. So if you just, you come to a roadblock and you immediately ask me, you say, Chapman Sensei, how do I do this? You're not going to get quite as much out of it as if you were to sit down and look at it and try to read through the question and try to understand what's going on. And a lot of the answers they're right in the lab manual. So if you're stuck and you don't understand like what's going on, you can just flip back a few pages, read through the lab manual and say, okay, well, it's telling me to do this. And everything should be very self-evident. So there shouldn't be any problems there. But please, if you do have a question, ask me. Number 8, academic honesty. It is expected that you'll do your own work. Cheating, plagiarism, and any academic dishonesty will not be tolerated. You are not allowed to share class information over the internet, and dishonesty will be dealt along with the university's guidelines to the fullest extent. So every semester, we have people who come in, sob stories about why they're failing the class because they cheated or whatever on an exam or practical. I have some stuff for you, student. So let's. Yeah, so every semester, like people come into the grad office with sob stories about I didn't cheat or whatever else, and we're all very strict about policy. We see cheating, we see plagiarism. You're going to get your 0, and we'll take it to the university because they have to start putting like a record together to show that this student is a problem and they need to deal with it or whatever. And plagiarism, that's an important one. So. That includes looking at your partner's answer. Even if you don't understand it, and your partner, you don't have partners, but like maybe your neighbor like tries to explain it to you. you have to put it in your own words, I don't want to see carbon copies of the same lab, I've gotten like 2 labs that are completely identical, just the handwriting is different and there's different names. So, of course, they're going to get zeros. So the grading criteria, I'm going to go on to the grading criteria now. There are 12 labs and the lowest score will be dropped. So if you do need to miss a lab, don't worry about it too much because the lowest score will be dropped, the 0 will be dropped. It's not a big deal. Final grades will be determined from the 11 labs at 10 points each, it's 110 points. There'll be plus 1 quiz, which is 15 points, and a comprehensive practical exam at the end for 35 points. That's a total of 160 points by the end of the class. There will also be weekly extra credit quizzes that I call knowledge sinks. You sort of sink all your knowledge into this quiz, and usually right at the very beginning, so you want to make sure you're on time every day because they're going to be at the beginning. They're purely extra credit, so there's no pressure to do well, there's no pressure to get it all right. But I do want you to attempt it, of course. And really, it's going to be based on the information from the previous lab. It'll be based on information gone over in the lecture, and it's sort of to help keep you, understanding where you're at. How many points are extra credit? How many points are the extra credit? Okay. So I'm gonna make them up usually on a weekly basis. Like I'll know, like, oh, that week, like, because I try to tailor the quizzes to the class. Like if the class is needs to work in a certain area, if I see that while I'm grading the labs, if need work in a certain area, I'll quiz you on that, and it might be worth anywhere from 2 to 5 points. It's going to be, since they're weekly quizzes, they're going to be worth not many points. Maybe lower, maybe like 1 to 2 to 3 points. And it's just, again, it's just so that you sort of know where you're at. You say, okay, I couldn't solve this quiz, then this is what I need to study for next time. Again, this is all individual work here. Yeah. And that's the grading distribution there at the bottom. It's used the plus minus system. So you can sort of figure out where you are based on how many points you've gotten for the handouts, the labs that I've handed back. And that is the syllabus. So now we're going to go ahead and do the safety training. So this is every lab you have to do the safety training. So at the very top, go ahead and put your name down. It's fine for training provided by, put Chapman Sensei, that's me. Our title, you can put Astro 154L, that's the lab. The date of training, today is what, the 29th? Says it on the computer. 16. 15. Okay. Subjects covered. General safety rules. So no eating, drinking, or smoking in the lab. So, we have a computer lab here. We want to keep everything as, nice and tidy as possible. We don't want Dorito fingers on the keyboards and stuff like that. So please say what you're eating for before and after the lab. I know it's at a weird time. It's from 11 to 2. So I haven't eaten yet, and I know people are probably hungry, so might miss your lunch. But please no eating in the lab. Drinking, again, bottled water is good. No open containers, no sodas or anything like that. No smoking, I think that's pretty obvious. No unauthorized experiments may be performed. So that's not really a hazard because we have computers here, and each experiment, you call it an experiment, but it's really just, it's an exercise. So confine loose hair, confine long hair and loose clothing, no open-toed shoes. I'm pretty lenient about the loose hair policy, so you don't have to worry about that. Wash your hands after using chemicals. We don't have any chemicals. So if you do bring water and you spill, just tell me immediately, and I'll grab napkins, I'll grab your towels or whatever, and we'll get it cleaned up. No horseplay. So we're all adults here. We don't need to be, having keyboard fights. We're throwing keyboards at each other across the room or anything like that. We just, come into the lab, be nice, no horseplay. So, okay, availability and use of personal protective equipment. Privileged eye protection, there's nothing there. We don't have any necessary eye protection. No safety goggles, no spectacles. There's really no, protective equipment that you'll need. I don't know, maybe if you want, Purell, you should maybe bring that. Basic emergency response procedures. First aid kit is located here in front of the room. So in that blank space, you can put, it's in the front of the room next to the globe. You can put that down there. Do not perform first aid unless certified. Have students cover, clean and cover their own minor injuries. So basically, if there's, if you somehow cut yourself on the computer monitor or something, just come tell me, we'll get you patched up, no problem. Let's see. Emergency eyewash stations, we don't have one in here. I don't expect anybody to be getting like integrated circuits in their eyes or anything like that. So we don't need that in here. Yeah, so we'll escort you to the health center if something happens. Fire extinguishers. The fire extinguisher is located by the door. It's to the right of the door, next to the trash can. It's a good way to put that, located there. And what we'll do is, if there is a fire somehow, maybe your computer explodes, and you gotta take care of it. I'm gonna take out that fire with a pass system. It's the P, I'm gonna pull out the pin, A, I'm gonna aim at the base of the fire, S, I'm gonna squeeze the handle, and S again, I'm gonna sweep from side to side. We'll knock the fire out, be very good. And in case of any accident, please notify me immediately. Don't worry about it, no one's gonna, we're all on the same team, nothing's gonna happen. Just let me know if something happens, and we'll fill out an accident report. If one of the computers doesn't work, let me know, please, and I'll talk to Lab Master Vic if you're about taking care of it. Hazards unique to the laboratory, nothing really. I mean, we just have computers, so should be all right. Yeah, and then you can just go ahead and sign there at the bottom, sign and date it, and when you're all done with that, you can go ahead and slide them off to the side. Yes.
Are we supposed to check these or initial?
You can initial them, you can check them, or you can leave them blank. It doesn't really matter. Just your signature at the bottom is really the only thing that matters. All right. So I'm going to come by and click them. Then we're going to do the intro lecture. Do the intro lecture, and then I'll hand you all a blank piece of paper for the lab. I'll get started on our work for today.
I have a quick question.
Sure.
Do we get a break during 3 hours?
No. There won't be a break, but after lecture, everyone's going to be on their own doing the lab, and you'll be at your own pace, so you can sort of relax then. Yeah, and if you finish quick, then you can skedaddle.
Another time of 3 hours, like a break in the middle.
Yeah, that's mostly for like lecture classes, I think. But with the lab, it's sort of free reign. You can do whatever you want within reason, of course. All right, so I'm going to go ahead and get started on the lecture for today. So this is going to be relevant to the lab for today, and maybe also for the little secret assignment that I have for you all. Just real quick, the secret assignment is going to be an anonymous assignment, so you don't have to worry about it too much. And it's extra credit. Again, today is like extra credit day, extra credit extravaganza. All right, so again, this is Astro 154L, and the first lab is going to be on the size scale of the universe. So it all begins, right, in our solar system, the magnificent glowing orb, our star, the sun. This is the life source of everything in our solar system. It's what keeps us alive every day and provides us warmth, light, and all that. This is the key to our solar system. It holds it all together. It's a gigantic gravitational sink right in the middle. and it's extremely large. Going outwards from the sun, you're going to have your planets, and here you have Earth. This is the planet that we live on, obviously. It's our home in this insane universe that we live in. And it's much, much smaller than the sun by a lot. I'm going to show you some of the scale. As we move outwards, you're going to see, as we move outwards from the sun, starting off at the center of the sun, as we move outwards in space, we're going to see that things grow larger and larger. Our perspective is sort of shifting outwards. And you'll start to see the craziness of the universe in the sense of how large and how small objects are. It might hopefully give you a little bit of a perspective on our place in the universe, like why we're here and all that. So here we have the terrestrial planets. We have Mercury, Venus, Earth, and Mars. These are the 4 rocky inner planets that exist in our solar system in order. Here we have the Jovian planets. So in between the terrestrial core planets, the core rocky planets, we have an asteroid belt, and then we have these Jovian planets, which are the gas giants, and they're many, many, many times larger than the terrestrial core planets, the inner terrestrial planets. And just looking at these planets compared to our star, the sun, you're going to start to see the perspective, and you're going to start to see the scale. You see here we have a tiny planet here. This is our Mercury here. And this is our planet Earth compared to the ridiculous size there of the sun. This is all in the solar system. You have your sun and these planets. And you compare our Earth here to these Jovian planets, the gas giants, and you start to see that we are quite small in comparison to the things around us. And this is just in our solar system so far. And here's another look at our solar system. You have all the planets. That's that asteroid belt I was talking about. And you have the this isn't to scale, but you have the inner core planets, the terrestrial planets. And you have your Jovian planets. You have your Pluto, which is a dwarf planet. Doesn't quite meet the criteria for a planet. Here, this picture is quite intense. It shows a little bit of the scale, the perspective. So here in ascending order from smallest to largest, right? You start with the smallest size and go up. You have your terrestrial planets, Mercury, Mars, Venus, and Earth. Here, you take the largest one in that group 1, Earth, and you make it the smallest one in this group 2. And so this planet here is Earth compared to your Jovian planets. And you take Jupiter and you expand outwards and look at the other stuff that's bigger. And here, that's Jupiter compared to these stars like Sirius in size. And this is our star, the sun. So this is Jupiter compared to the sun. And this is the sun compared to Sirius. Now, if you take Sirius and you sort of grow outwards and look at the other bigger stars, here's this large star compared to our sun. Sirius here, it's like a tiny marble compared to that ridiculous star there. Again, you take that star and shrink it down to here. Compared to Betelgeuse there, this star is that, you see the trend to them. And then all compared, here's Betelgeuse in a small orb compared to Canis Majoris there. So if you start to look backwards and you try to compare Canis Majoris to, say, our sun, it's kind of mind-boggling, right? Like the size scale difference is pretty intense. I have another picture that sort of illustrates that pretty well. This one here. So if that's Canis Majoris, the largest star on the other slide, that tiny dot that you can't see on the smaller scale there, like magnified by a lot, is our sun, which again is compared to Earth, that. Sun compared to that tiny dot there, Earth. So our star is pretty small in comparison to what's around us. Beyond stars, we have these things called planetary nebulas. You see here's some planetary nebulas, and we have some nebulas here in the paintings around the room, the pictures. And it's the death of a star. That's what it is. It's the death of a size star, maybe around the size of the sun. Our sun will undergo planetary nebula change. What happens is the star expands out to be a red giant, and then it blows off its outer shell of gas, and that gas expands outwards in different directions and creates these gigantic plumes of gas. And in the very center of it is the core, the white dwarf core of the remnant of that star. Then they become this planetary nebula. So when a star dies, it becomes a planetary nebula. It expands, the total size of the gas region can be a couple of light years across. So Expands out quite a bit. And a light year is the distance. It's the distance light travels in a year. And light is 3 times 10 to the 8 meters per second squared. That's the 3 times 10 to the 8 meters per second. That's the speed of light, not squared. So light being the fastest thing in the universe, however long it travels in 1 year, the distance, that is 1 light year. So expanding outwards from our solar system, after getting past the Kuiper Belt New York cloud, we have here our solar interstellar neighborhood. And the red ink there that you can't really read on the thing there, that's our solar system compared to the stars around us. So these are our nearest neighbors, the nearest stars nearby. So we're panning outwards, you know. And these groups of stars, these neighborhoods, they comprise like many, like millions and billions of these stars are comprised, they all make up the Milky Way galaxy. And this is the galaxy we live in. It's got the supermassive black hole in the center, Sagittarius A, I think. And this galaxy, of course, yeah, it's made up of billions and billions of stars, all like our own or much bigger, like you've seen in the scale pictures. And this is our local galactic group. So if you expand again, if you keep going outwards past our galaxy, if you fly outwards in your mind, you start to see that there are other galaxies nearby, and you can see other galaxies. You can't really see it. I've seen a galaxy. I've seen Andromeda using a telescope, so you can see them, not with a naked eye, but as you go further and further out, you start to run into more galaxies, and this is our local galactic group, it contains our Milky Way galaxy, it contains the nearest spiral galaxy there, Andromeda. And if you expand outwards even further, and so you're like, the scale is shrinking, right? You're looking at, here's your galaxy, and now your scale is shrinking down, and you're kind of looking further out to shift your perspective. You have the Virgo Supercluster. So these are all clusters and groups of galaxies. This material, these are all different clusters of galaxies. There are larger clusters of galaxies, and there's smaller cluster of galaxies. Our galaxy cluster is kind of on the smaller size, but there are larger ones and this creates the Virgo supercluster. There's all these clusters of galaxies. And this is a group of the local superclusters. So each group here, each little blob of light is made up of superclusters, which are again like groups of galaxies, like many groups of galaxies, which are many groups of stars, which are many groups of solar systems like ours. Expanding even further outwards, we have the Observable Universe, the Virgo Supercluster there in the center, because the way light works is it's the Observable Universe. It's the amount of time it takes light a certain amount of time to reach us. Light is the fastest thing in the universe, and we can only see so many years out because that's how long, it's taken. There's light beyond it maybe, but it takes longer than there is time in the universe for that light to have reached us. It just hasn't traveled to us yet. So this is our Observable Universe, the Virgo Supercluster there, in comparison to everything. And if we come all back, here we are on Earth, looking up at the night sky, looking up at our Milky Way galaxy. And I don't know, kind of puts it all in perspective maybe. The universe is an extremely large place. So that's the intro lecture. I'm going to hand out hopefully this is up here, but I'm going to hand out the lab. Everybody got one? So this is the first lab. It's the size scale of the universe. At the top, you see you have 5 pictures there. You know, you have A, Saturn, B, galaxy, Sun. You have the astronomical unit, the distance from the Sun to the Earth, and you have F, the local solar neighborhood. So I want you to kind of like this picture here. Actually, exactly like this picture here. I want you to rank them in ascending order from smallest to largest. So again, we took our terrestrial planets and we sort of like went through and scaled it all together and listed it in order from smallest to largest and increasing size. I want you to do that with the 5 pictures there. You can just write the letter like A, B, C, or whatever in a spot appropriate. 2, it says where would a planetary nebula fit in the list? So rewrite the list, but place the planetary nebula where you would expect it to be. Again, planetary nebula is about, you know, could be anywhere from like 1 to 2 or more light years across. So it should fit pretty well in here. You can use the internet for this lab. I'm making a special exception for this lab. You can use Google, but don't just Google the answer. But like if you want to look up, okay, what's the astronomical unit size? Let's look that up because that'll help you. You can find out the actual size of the astronomical unit compared to maybe the diameter of the Sun, and that'll tell you which of those 2 objects is bigger, right? So you can do that. And then 3, where would a galactic cluster fit? You can just use PNE to denote your planetary nebula for number 2, and you use GC to denote the galactic cluster for number 3. Number 4 is a bit of a math question. It's the only math question. Number 4, it says the speed of light is approximately 3 times 10 to the 8 meters per second. If the Earth is 1 AU from the Sun, 1 astronomical unit, and 1 astronomical unit is approximately 150 times 10 to the 6 kilometers, how long does it take in seconds for the light of the Sun to reach us on Earth? So the trick here is to know the formula that you know, time is equal to distance over velocity. Velocity is equal to distance over time, right? Velocity is meters per second. So velocity is meters, which is distance, divided by time, which is second. So if you rearrange that using algebra, you can get time is equal to distance over velocity. I gave you the formula there. So you just put your distance, the AU, there, and you divide it by the speed of light, and it should give you your time in seconds. The trick is, you know, I gave you the AU in kilometers, so you'll have to convert it to meters, or you have to convert the speed of light to kilometers per second. So a little conversion there, but not too bad. You can use Google if you get stuck. So that is the lab. When you're done with it, you turn that into me, and you will be done for the day. For the most part, with the lab as well. But I have a little extra thing here that I'm going to hand out. Yeah, so yes,
Would you prefer that we write everything down here? Or?
Oh, no. So I handed back a piece of paper. It's for a different assignment entirely. I'm going to tell you about it. Yeah, I'm going to get extra stuff. Yes. Oh, okay. Please raise your hand if you need paper. Blank paper. So what I want you to do on the blank paper is, I just want.
It's just like understand.
So for the blank sheet, I want everybody anonymously, right? So you don't have to put your name on it. I want everybody to write to me and say like, oh, what do you think of the universe? Like, when you think of the universe, how does it make you feel? What do you think about it? Do you like space? You have a favorite space movie, maybe? Maybe you think the space sucks and you're only here because you need to. That's fine. I just want to get an idea of everybody's opinion on the universe. Bless you. So yeah, just a little assignment, completely anonymous. I just want everybody to tell me what you think, bless you, about the universe. So I'm going to pull up the question. Okay. So I'll give you all a little hint. I'm gonna put this picture on the Moodle maybe. I need to finish doing the Moodle, but I'll have it up in the syllabus, and the first intro slides will be on syllabus, they'll be on the Moodle. But this is a highly interesting image here. It shows that you have the Earth there, right, the far left, and you have the Moon. That's the distance between the Earth and the Moon. And you took every planet in the solar system and you put it next to each other side by side. They would all fit between the Earth and the Moon. So every planet would fit between the Earth and the Moon with 4,990 miles to spare. So it's just a little hint on the scale, because if that's the planets, those are the planets, and that's the distance between the Earth and the Moon. You see here number D, the distance, the astronomical unit. That's the distance between the Earth and the Sun, which is obviously it's quite a bit further away than us to the Moon. Moons are the nearest thing that we have in the solar system. The Sun's a bit further away. So I'll just leave that up, I guess. So that's it. You get the intro assignment, a little extra credit anonymous thing. And the way I'll do the extra credit is if more than 2/3 of the class turn it in, because if you don't want to turn it in, you don't have to, I guess. But if more than 2/3 of the class turn in the anonymous, this is what I think about space assignment, I'll give everybody in the class extra credit points. So, yeah. If you have any questions, please don't hesitate to ask. Yes, I'll come back.
with a pressure of Saturn, but once you got this order down, yeah. Once you got that order down, they introduce a plan technology. So they where it would be maybe it's on A and B. So it's, whatever your list is, but this one. Yeah. Oh, and then the next one is this list is put here. Then you find where it's I love that. It's so cool. Okay. Yes. Because you have your kilometers here, right? You have your whole present return to root, and you can't send it kilometers. This is now being used in your house. So just do it. Just slap in your calculator. Yeah, it's off by a couple of orders. Five looks good. You're up by a couple of orders. So it doesn't. Yeah, because your math is right. You just want